Good evening. This is Mrs. Boland with the University of West Florida College Algebra, and we are doing section 6.4, which is the graph of the logarithmic functions. The first thing I want to remind you when we talk about the logarithmic functions is the fact that the logarithmic function is the inverse function of the exponential function. So we've already discussed the exponential function. You've learned how to graph them. Hopefully you've done your WebEx homework and you've done that well. You learned that the exponential was a one-to-one function. When you know that something is a one-to-one function, that means that its inverse is also a function. Well, just like we have a special name for the exponential function, the inverse of the exponential is called the logarithmic function. And that's what we're going to be talking about today. Remember that when we have a function and its inverse, if we have whatever the domain is for the function, becomes the range for the inverse. And whatever is the range for the function becomes the domain for the inverse. So as we study today, you're going to be seeing that correlation for the logarithmic function, which is simply the inverse of the exponential function. Alrighty, so the characteristics of the graph of the parent function of the log base b of x. Now that's called base b, so log base b of x. So for any real number x and a constant b, which has to be greater than 0, and it cannot equal 1, we can see the following characteristics of the graph for the function log base b of x. First off, it's a one-to-one function, which we already knew because we know that the logarithmic function is the inverse of the exponential, and we know the exponential is a one-to-one function, which means its inverse is obviously a one-to-one function. With the exponential, we had a horizontal asymptote, and so with the inverse, we have a vertical asymptote, and so that is going to be the y-axis, okay? The y-axis becomes the vertical asymptote for the logarithmic function. The domain is all real numbers that are positive, okay? Which is exactly what you would expect, simply because the range of the exponential function is 0 to positive infinity. So you would expect that to be that correlation. Our range for the logarithmic function is all real numbers, which makes perfect sense because the domain of the exponential function is all real numbers. Now, we have one known point. They call it a key point here, and that is the x-intercept, and that occurs at the point 1, 0. Doesn't matter if it's an increasing or a decreasing function, the key point, the one known point, occurs at the point 1, 0, which is very similar, if you think about it, to the exponential function, because the exponential function has one known point, and that is at the y-intercept of 0, 1. Okay, there is no y-intercept for the logarithmic function. We have an increasing function if b is greater than 1. So an increasing function. See, we're increasing. And if b is between 0 and 1, we have a decreasing function. We can slide down the slide, okay? So again, whether we increase or whether we decrease depends on the value of b. Now, b can never be negative. You have to remember that. Here's our basic rules for the shift, okay? So it says if we have a parent function and we add to the x, if it's a plus sign right here, we know that x always lies to us, right? So just remember that if we have a shift that has to do with x, x lies to us. That's why they are your x, okay? And so if it's a positive sign, we know that we're really shifting to the negative direction. And if it's a negative sign, we really know that we're shifting to the positive direction. So remember that. The domain can be adjusted by -c and the range, or all real numbers rather. For any constant, we can have a vertical shift right here, and the shift is going to be according to whatever the sign is. So if it's positive, you're going to be going positive y direction. If it is negative, you're going to be going down in the negative direction on the y-axis. We have our vertical asymptote. If all we have is a vertical shift, the asymptote remains the same. Our domain is going to be all positive real numbers, and our range is all real numbers. Going back up to this one right here, I forgot to cover the fact that if we have a shift to the right or left of the parent function and our one known point, that our vertical asymptote is always 1 unit on the 1 unit off of the one known point. And that would also then be equal to negative c. So let me show you how you find all this. It says state the domain, the range, the x-intercept, and the vertical asymptote of each function. So let's look at that and we'll get busy. All right, when we look at this first function right here, there is no horizontal shift, there's no shift connected to the x, and there is no vertical shift either. So this is just a parent function that has either been stretched or compressed based on its b value, okay, of our base. And so it's very similar to the parent function. So when we sketch this particular graph, and I say sketch because I'm not plotting all the points particularly, okay, we have no shift either direction, so we know the one known point is still going to be here at the point 1, 0. So that's one known point that we have. And now we're going to look at our b to see whether we're an increasing function or a decreasing function. And our b is equal to 6. And if you come back up here to our rules, when b is greater than 1, we have an increasing function. So this is going to be what our function looks like for the parent with a vertical asymptote of the y-axis. So it's going to look just like this. Okay, so our domain, if you look at this, okay, what x values can we equal? Our domain is going to be all positive numbers. So our domain for this function is going to be from 0 to positive infinity. Our range right here is going to go all the way down to negative infinity and all the way up to positive infinity. So our range is all real numbers, or written in interval notation, negative infinity to positive infinity. The next thing I need to look at is the x-intercept. Well, that happened to be our one known point, and there was no shift. So our x-intercept is the point 1, 0. And then the last thing it asked is, what is our vertical asymptote? So our VA is going to be the y-axis, so that is x equals 0, because that means no matter what, x always is going to equal to 0 to identify the y-axis. Alrighty, let's look at problem B. So problem B says, first off, let's look at our domain. Well, let's go ahead and just do a quick sketch of this, okay? Just a quick sketch. So we're going to put our x-axis and our y, and notice it's x plus 5. If you can't remember which way you shift, okay, you can always just solve and see that it is x is equal to, in this case, negative 5. Because if we go x plus 5 equals 0, to move it over, it's going to be x equals negative 5. So we're going to have our one known point right here. This is the point 1. And I need to shift left 5 units. So we're starting here. That's 1 shift, okay? And then 2, 3, 4, 5. So again, we start from here. 1, 2, 3, 4, 5. So this right here is going to be our new known point. So let's see here. That's negative 1, negative 2, negative 3, negative 4. So our new known point, which is also going to be our x-intercept, is the point -4, 0. Alrighty, now at -5 is going to be our vertical asymptote. And we'll just draw it in here. We're just going to squeeze it right on in. So that is at the point x equals -5. And our graph looks like this. Whoop, let's look at our base. Got to look at our base to know if we're increasing or decreasing. You'll notice there's no number written there, right? So remember that when there's no number written there, by default, it is a base 10. So this is really log base 10 of x plus 5. And 10 is definitely greater than 1. So it is an increasing function. And so it's going to look like this, okay? I don't know exactly where it's crossing my y-axis, okay? I don't know the y-intercept, nor am I being asked to calculate it, so I'm not going to worry about it. Since this is a sketch, I'm not going to label that point because I don't know exactly where it occurs. So I need to write down my domain. My domain, if you look, it's going to come all the way over here to -5 and then positive infinity. So -5, positive infinity. And your domain is always going to be referenced off of your vertical asymptote, and that's always going to have something to do with your shift right here. So the next thing I need to know is my range. And if you look, you can see that your range is going to be all real numbers. So our range is this, or -infinity to positive infinity. I need to know my x-intercept. X-intercept. My next point here, my x-intercept is the point -4, 0. And then the last thing I need to write down is my vertical asymptote. My vertical asymptote is going to be x equals -5, which is, if you solved it, right up there, okay? So x equals -5. Okay, let's move on to our next problem. Problem C. Notice again, I do have a horizontal shift. I do not have a vertical shift on this one. That's going to look like this. We're just going to do a very quick sketch again. It's good just to take a moment. You see, it doesn't take long to do a sketch, and it can really help you on your exams. So we're just going to put a few dashes here and a few this way. We have x minus 4, so x minus 4 equals 0 means x equals 4. So in case you can't quite remember, just write it down like this, okay? We're going to start with our one known point, which is going to be right here. That's where we start. Now we're going to do a shift on the horizontal axis in the positive direction 4 units. So we're going to start here, and we're going to go 1, 2, 3, 4. And this is going to be the location of our new known point. This would be the parent. This is the new known. So I'm just going to come in there and grab that right there and pull that on out. Now let's go ahead and dash in our vertical asymptote. Just make it a dotted line to the best of our ability. And now we're going to draw the function. Because 2 is greater than 1, we know that we have an increasing function. I didn't write that down in the others, but I did verbally speak of that. So our increasing function is going to look just like that right there. Now let's go ahead and identify our domain. Our domain is going to be referenced off of our vertical asymptote, and that is at 1, 2, 3, 4. So it's going to start from 4 and go to positive infinity because it's going to go this way. Our range, as you can see, is all positive and negative numbers. So it's all real numbers, or written as negative infinity to positive infinity for interval notation. Next, we need to look at our x-intercept. And our x-intercept is going to be the point right here. So it's 1, 2, 3, 4, 5. So it's the point 5, 0. And then the last thing we need to look at is the vertical asymptote, which I always abbreviate as VA. Okay, so our VA is going to be x equals 1, 2, 3, 4. And remember, it's just right up here. X equals 4. Okay, so grab this information from right here, and that will give you your vertical asymptote. Alrighty, I hope that this is making good sense to you and that you're understanding this well. Now we're going to be graphing logarithmic functions. Next, I should have let you do that last problem on your own and have give you an opportunity to work that. Sorry that I didn't. I'll give you a couple of opportunities in this lecture. So graphing the following function by finding the vertical asymptote and plotting 3 points on the graph. So that's what we've been asked to do. There's a couple different ways of plotting the points, and I'm going to show you different techniques, and then you just use which one you feel most comfortable with and that works consistently for you, okay? So that's what's important. Remember, in algebra, often there's many different ways of solving a problem. Just choose what works for you and then go with it, okay? As long as it's not like, looking at your neighbor's paper. So that would be the only time that it wouldn't work well. Okay, so it says graph the function log base 3 of x. Well, I know what the sketch is going to look like. There's no vertical or horizontal shift. It's just a base 3, which tells me that I'm an increasing function, and it has to do with the stretching and the compression and things of that nature. So that's all, okay? So we know that the basic function is going to be that our horizontal asymptote is going to be our y-axis. We know that because there's no shift, that our y-intercept is right here, and we know we're an increasing function because 3 is greater than 1, and so that's the basic sketch. But we were told to identify the vertical asymptote and 3 points, so we shall do that. The vertical asymptote, as you can tell, is the entire y-axis, so our VA is going to be x equals 0. Okay, so we have that done. The next thing that I need to identify are 3 points. So we're going to do x and y, and I'm going to choose 1, 2, and let's throw in 0, or instead of 0, we'll throw in 0.5. Okay, and yes, I kind of looked at those ahead of time before I chose them. I'm going to show you a couple of different ways, again, to solve these. So our function is right here, and if I have, let me get a thinner ink here, there we go. If I say log base 3 of x, and x is equal to 1, I can go log, well, if my computer will write here, log base 3 of x. X is equal to 1 equals y. Now write this in an exponential form. So this means 3 to the y equals 1. Well, in order for that to be a true statement, what must y equal? Y must equal 0. Do you agree? So we'll put 0 right there, which makes perfect sense. This gives me my x-intercept at the point 1, 0. So that works out very well. Let's look at 2 and solving it the same exact way. So if I'm looking at 2, it's going to be log base 3 of 2 equals y. So now I end up with 3 to the y equals 2. Now that's a little bit harder, isn't it? Okay, it's going to take a little bit of work to figure that one out. So we're going to use a different technique for solving that one. And the technique that I'm going to use is this one right over here. I'm going to say if I want to find f of 2, okay, so I'm going to plug in x equals 2, that is going to be equal to log base 3 of 2. So I'm going to show you a different way of solving this, and I have a little rhyme that a student taught me a few years ago from this course, and it's log of the tall over the log of the small. And it's just a little rhyme, but it helps you understand the division. So the rhyme is the log of the tall over the log of the small. This is the tall number, this is the small number. So if I need to calculate this, because this is a base 3, your calculator cannot, if you're using one that's allowed for your exams and stuff, and for this course, will not be able and capable of solving a log base 3. Okay, it's not going to be able to do anything but a log base 10 or a log base e, period. So this is a log base 3. It's not, you don't have a calculator to do that. So there's a technique, okay, there's a math way of working around this, and it is this right here. This log base 3 of 2 is equal to log base 10 of 2 divided by log base 10 of 3. It doesn't have to be base 10, it just has to be the same base. So it could be base 2, 3, 4, 5, but your calculator only does a 10 or an e, okay? So either you're going to take a log base 10 of 2 divided by log base 10 of 3, or you're going to take the natural log of 2 divided by the natural log of 3. Because that's what your options are, okay? So if you can't remember, which ones go which, just remember this little rhyme. The log of the tall divided by the log of the small, or over the log of the small. So grab your calculator right now, and I think I've got a calculator picture here. Let me see here. So the way you're going to calculate this on this calculator, which is a TI-30XA, you're going to first put in the numerator, so it's going to be 2. So you're going to come down and hit 2. Then you're going to hit log, so you're going to come right up here and hit log. Then you're going to hit divide, so you're going to come here and hit divide. Now you're going to hit 3, so you're going to come right here and hit 3. You're going to hit log again, and after you hit log, you must hit equals, okay? So that's how you're going to do that, and when you do that, you should get 0.6309. Okay, so I'll write that down real quick. So that'll equal 0.6309. So that is going to be the value that goes right here, 6309. Okay. Now let me go ahead and move this back on down to our next problem. Okay, so now I have one more point right here to do, and that is 0.5. And so we're going to do the same thing. We're going to calculate this the same way by converting to a base that we know. So I have f of 0.5 is equal to log base 3 of 0.5. And that is going to be equal to the log base 10 of 0.5 divided by log base 10 of 3. Okay, so I'm converting to a common base, and it's going to be the log of the tall divided by the log of the small. And again, when you put this in your calculator, you will get negative 0.6309. Very similar to the other, but it's a negative. So make sure you practice that on your calculator so you know how to do that. And you may go ahead and practice doing this method right here on this part of the problem, and you'll see that it does equal 0. So I could go ahead and plot those 3 points, but I'm not going to. I've already got my sketch done, and I'm satisfied with that. But you can feel free to plot yours more precisely if you would like. Let's go to the next problem here. And we have the exact same directions. We are to state the vertical asymptote and also provide 3 points. So our vertical asymptote, you're going to notice that we have a shift right here. Normally our one known point is right here, but we have an x minus 1 equals 0, which means x equals 1. So at x equal 1, that's actually going to be our asymptote. And so we'll draw in our vertical asymptote right there. And if that's our vertical asymptote, we know that our one known point is shifted here. There's no vertical shift, so it's going to stay right there at the point 2, 0. And that will then be our x-intercept. We're asked to solve some points, so we'll do x, y, and we're going to do the point 2, 1.5, and 3. So let's go ahead and look at this. So if I evaluate f of 2, that's going to be log base 2 of 2 minus 1, which is going to be log base 2 of 1, right? And now I don't have a common base, so I can go, this is going to be equal to log of 1 divided by log of 2. And if you grab your calculators, you are going to see that is equal to 0. Option number 2, if we wanted to, we could take it from this point right here, log base 2 of 1, and we could say log base 2 of 1, set that equal to y, and we can turn around and we can say 2 to the y equals 1. Well, again, what values must y equal to make this a true statement? Y will equal 0. Okay, so both techniques yielded the same answer. Let's look at f of 1.5. So this is going to be log base 2 of 1.5 minus 1. 1.5 minus 1, which is equal to log base 2, 1.5 minus 1 is 0.5. So this is going to equal log of 0.5 divided by the log of 2, and that is going to equal to -1. So that's -1. We can look over here and we can say, if I have log base 2 of 0.5 equals y, that is equal to, means that 2 to the y is equal to 0.5. Well, 0.5 is also 1 over 2. Do you agree? So what must y equal to make this whole thing 1 over 2? Well, y would have to equal -1, because if I say that this is equal to 2 to the -1, that would be rewritten as 1/2, which equals 1/2. So therefore, y would equal -1. So there's another way of solving that y would equal -1. Alrighty, let's look at 3 here. Actually, I'm going to let you solve that particular one. Okay, so pause the video, solve f of 3, and when you are done, push play to see if you got the right answer. Okay, I'll see you back in just a moment. Okay, welcome back. So let's see here. This would be log base 2 of 3 minus 1, which is equal to log base 2 of 2, which equals log base 10 of 2 divided by log base 10 of 2. Same thing, so that's going to be equal to 1. That would be one option of solving for this. Let's look at another option. If I have log base 2 of 2, I can go log base 2 of 2 equal to y, rewrite it as an exponential. So it'd be 2 to the y equals 2. So 2 to the y equals 2. What must y equal? Well, y must equal 1 in order to make this a true statement. So there you have it. If you got this right, using either technique, this one right here or this right here, send me the code word orange. Code word orange. And if you got it wrong, I'm proud of you for trying. Send your instructor the code word lemon. Okay, yes, I've got oranges and lemons sitting in front of me. What can I say? So, our last bit of fresh fruit before we end up being locked down for however many days, right? So, here we go. Let's find our next problem here. This is a really great problem. I love working on this particular problem. Okay, so here we go. So our function is f of x is equal to -4 plus log base 4 of x. The first thing I want you to notice is if we rewrote this right here, if I switch it around, I can write it log base 4 of x minus 4. So I can clearly see that I do not have a horizontal shift, but I do have a vertical shift down 4 units. So my one known point, which is normally right here, is not going to shift right or left because there's no horizontal shift, but I do have a -4, so I'm going to shift down 4 units. So I'm going to go down 1, 2, 3, 4, and that's my one known point. 4 right here, this 4 right here, 4 is greater than 1, therefore it's an increasing function. And so I'm going to have a function that looks like this. I did not calculate the x-intercept, so I don't know actually where it actually crosses. I just simply drew something. If I remember correctly, it does. We'll calculate the points. I think it takes a much sharper turn if I remember correctly. And now I'm going to go ahead and just highlight the vertical asymptote, which is going to be the y-axis. Okay, so that's a general sketch where the vertical asymptote is known, the one known point is shown, and the general shape of the graph is given. I am told that I need to calculate some points, so let's go in here and do that. So I have x and f of x, also known as y, right here. So the points I'm going to choose are going to be 1, 2, 4, and 256. You'll see why in a minute. I know that sounds a little strange. Okay, so let's go ahead and start calculating our values. Okay, so the first thing we want to do is calculate when x equals 1. So we're going to calculate f of 1. And that's going to be equal, I'm going to use this right here, -4 plus log base 4 of 1. So what I need to know is this right here. I can calculate it 2 different ways. I can do log of base 10 of 1 divided by log base 10 of 4. So I could take and just write this up over here, and I can go log base 4 of 1 equals w, and then I can go 4 to the w equals 1, therefore w equals 0. Okay, because that's the only value that would make that true. And I chose w because I'm really solving this whole equation over here for y. So this isn't y, this is just this part right here. So that I know then that this is equal to -4 plus 0, which equals -4. So that is what y is equal to. So next I'm going to calculate f of 2, which is going to be equal to -4 plus log base 4 of 2, which would be negative 4 plus log of 2 divided by log of 4. I can also come over here and I can say log base 4 of 2 is equal to w. So 4 to the w equals 2. Well, that would mean that I have to take the square root of 4, right? So if I'm going to take the square root of 4, that would be written as 1/2. So 4 to the 1/2 is the same thing as saying I'm taking the square root of 4. So in that case, w is equal to 1/2. So this right here is equal to 1/2, which you could also put in your calculator. So this is negative 4 plus 0.5. So this is equal to negative 3.5. So negative 3.5. Next, we have the number 4. So this is f of 4. Pause the video, solve f of 4 on your own. Welcome back. I'm going to finish and hopefully you got it right. So this is going to be negative 4 plus log base 4 of 4. Log base 4 of 4, do you remember what that equals? It would be the log base 4, or log base 10 of 4 divided by log base 10 of 4 if we were doing the division, which is just 1. Also, you could say log base 4 of 4 equals w. So 4 to the w equals 4. Therefore, w equals 1. So this right here, either way that you go, is equal to 1. So negative 4 plus log base 10 of 4 divided by log base 10 of 4. So that's negative 4 plus 1, which equals negative 3. How'd you do? If you got this one right, send us the code word painting. Okay, the code word painting. One more, 256. I want to see how many of you guys can get 256. Take a minute, work on it, and just pause the video, and when you're done, push play to see if you got it right. Okay, welcome back. I know this looked like a little bit of an odd number to use, but there was a reason, and you already figured that one out if you got it correct. So this is going to be log base 4 of 256. Okay, now let me move this up just a little bit. Log base 4 of 256. If I go log base 4 of 256 equals w. Write it as an exponential. 4 to the w equals 256. So now what I'm going to have to do is try to get 256 to base 4. So I need to find out 4 raised to what equals 256. So grab your calculators. Let me grab the calculator here. So to solve this, the first thing you're going to do is you're going to put in 256. So 256. Then you're going to hit the second button. Then you're going to come in here and hit this y to the x because you're saying you need to take the fourth root. But now you need to tell it to take the fourth root. So you're going to hit 4, and then you're going to hit enter, and you're going to see it comes back with 4. So that tells you that the fourth root of 256 is also equal to 4. If you want to double check that, you can reverse that by saying, what is 4 raised to the fourth power? So it would be 4 raised to the fourth power, and then you hit enter, or equal rather, and then you would find that it equals 256. So that's how you can verify that the fourth root, or 4 raised to the fourth power, is 256. So right here, it's going to be to the fourth power, so that means w equals 4. So right here, I'm going to end up with negative 4 plus positive 4 from right here, which equals 0. So the reason I chose this number right here is because that gives me my x-intercept. And I kind of wanted to know where that was at. And as you can see, it's definitely not here. It's way over here before we cross that 256. So this really takes a very sharp turn and goes a long way before it crosses that x-intercept. Alrighty, if you solved that one correctly and you got it right, send me the code word HONEY, HONEY. And if you gave the good old college try, but you didn't quite get it right, send me the code word bee, B-E-E, like a honeybee. Okay, here's our last problem. I'd like you to go ahead and pause the video and just tackle this on your own as much as you can. Just do as much as you can. What I'm looking for is your one known point. Did you get that correct? Did you graph it correctly as an increasing or decreasing? Did you locate your vertical asymptote? And then can you please calculate 3 known points? I'm going to calculate the x values 4, 5, and 6. So why don't you go ahead and use your x values of 4, 5, and 6, and then that way you can check your work a little bit easier. So pause the video, and I'll see you back in just a moment. Alrighty, welcome back. So the first thing I said I wanted you to do is plot your one known point. You know, we start right here at the point 1, 0, but I have a shift here. I have an x minus 3 equals 0, which becomes x equals 3. So now I know I have a positive shift, and I know that my vertical asymptote is actually going to be right here. At x equals 3. So my VA is going to be x equals 3. My one known point, which normally is right here, I'm going to shift it to the right 3 units. So it's 1, 2, 3. And then I'm going to shift it down 2 units, 1, 2. So here's my new one known point. I'm going to have an increasing function. And so it looks something like this. I'm not asking you to calculate your x-intercept at this point in time, so don't worry about where that crosses the x-axis. Now, I need to find a couple of known points, x and y, and I told you earlier that I would calculate 4, 5, and 6. Okay, so the first one I'm going to calculate is f of 4. So this is going to be log base 3 of 4 minus 3 minus 2. So this is going to be log base 3 of 1 minus 2. Now log base 3 of 1 will equal to log base 3 of 1 equals w. This is 3 to the w equals 1, therefore w must equal 0. So this is going to be equal to 0 minus 2, which is negative 2. This right here equals 0, so it's going to be 0 minus 2. My next one is f of 5. I'm going to scroll up just a little bit. And so this is going to be equal to log base 3 of 5 minus 3 minus 2. So this is going to become log base 3 of 2 minus 2. And so this is simply log base 10 of 2. So this is going to be log base 10 of 2 divided by log base 10 of 3 minus 2. And when you punch that in your calculator, you're going to get negative 1.369. Negative 1.369. Negative 1.369. And then the last one is when x equals 6. So this is going to be log base 3 of 6 minus 3 minus 2. This is going to be log base 3 of 3 minus 2. And you can kind of recognize that this log base 3 of 3, when that equals w, this is going to be 3 to the w equals 3, means w equals 1. Do you see that? So this is going to be equal to 1 minus 2, which is negative 1. Alrighty, how did you do on those? Did you get all of this correct right in here? I hope that you did. If you did, send me the code word winter. And if you didn't get it correct, send your instructor the code word summer. Okay? And guys, make sure you send these code words, because this is how we are taking attendance. And if you don't send the code word for 6.4, if you don't send the code words, you're not marked for attendance, and you're going to get a 0 absence marked for that lecture. And as you may recall, you get bonus points at the end of the semester as long as you have at least a 70 average or above in your college algebra course. If you have perfect attendance at the end of the semester, you will have 3 bonus points added onto your final grade. So let's say at the very end of the semester, you end up with an 87 average and you have perfect attendance. That will take you from a B to an A minus, because that will equal a 90. So just by watching your videos, sending in your code words, you're going to get benefits. If you end up with 1 absence, you get 2 bonus points. And if you have 2 absences, you get 1 bonus point. If you have 3 or more absences, you don't get any bonus points. Or if you have an average below 70, you don't get any bonus points. So please take time to email or text your instructor the code words, because we are keeping track of all of this. Alrighty, here we go. Next problem here. Last page. Almost done. So starting with the equation f of x is equal to log base 6 of x, write the equation that results from shifting it left 9 units, shifting it down 4 units, and reflecting about the x-axis. So here we go. So our parent function is f of x is equal to log base 6 of x. I need to shift it left 9 units. Remember, x always lies to us, and if it says we go left, we must add. So if we're going to the negative direction, we're going to add 9 units. So there's that, okay? Now it says we're going to go down 4 units, subtract 4. We have just shifted it down 4 units. And now it says reflect about the x-axis. That means I put a negative right out front. And we're done. Okay. The next one, number 4. It says starting with the equation, f of x is equal to the natural log of x. So f of x is equal to the natural log of x. Okay. And it says write the equation that results from shifting it right 2 units. If I'm going right, that is actually shifting it in the positive direction. So my sign must be negative, because x always lies to us, okay? Then it says up 7 units. So that's outside, not connected to the x, is a y shift up 7 units. So that's positive 7. And then reflected about the y-axis. And that means I'm going to put a negative right in front of the x right there. That takes care of the reflection about the y-axis. And there's our equation. Okay. This one here says below is a graph of f of x, the natural log of x. That's this parent function right here. And it says match the other functions with their graphs. So we have this function, this, and this. And what I want you to do is I want you to kind of look at these on your own and see if you can match them up. Pause the video. Just go ahead and pause the video. Once you have them matched up, push play to see if you got them right. I'll see you back here in just a moment. Okay, welcome back. The first one I'm going to look for here is simply the natural log of negative x. So that is going, there's no horizontal shift, there's no vertical shift. All I have is a reflection about the y-axis. And that's going to be this one here because the parent function is right here. If I were to divide this axis right in half, if I was to fold the paper right in half, it would reflect right over, okay? So this one right here, b, is f of x is equal to the natural log of negative x. Looking for this one right here, notice I have a shift of positive 4 units in the vertical direction. The only one that went up 4 units is this one right here. So this one right here, and you can count the point right here, our one known point, 1, 2, 3, 4. Bam, there you go. So right here, this is f of x equals 4 plus natural log of x. Okay? And then this one right here is a shift in the positive direction 2 units. We take our one known point and we go 1, 2. And there you have it. So A is f of x is equal to the natural log of x minus 2. Well, you know what, guys? This wraps up our lecture for today. If you made it to the very end of this lecture, I am so proud of you. I need you to email your UWF professor the code word "raindrops keep falling on my head." Okay? Love that song growing up. So you probably have never even heard of it. You'll have to take and look it up on Spotify. So "raindrops keep falling on my head" is the code word for the fact that you finished this lecture and you watched it all the way through. I'm proud of you. Your instructor's proud of you. High five. Go tackle your homework because we've learned that if you'll tackle your homework within 30 minutes of a lecture, you will actually raise your class score by 1 grade point, or not grade point, but 1 letter grade. So if you're normally a B student, by always doing your homework within 30 minutes of any class, you will actually turn yourself into an A student. If you're normally a C student, you will turn yourself into a B student just by tackling that homework within 30 minutes of a lecture for any course. So go tackle your homework, bump your letter grade up, and if you're already an A student, just become an A+ student. So take care, have a good day, and don't forget to send your instructor at UWF those code words because we're marking it down in our attendance book. Take care and have a great day.